All right, we are at the 5, so let's get started. Hello, everyone. Welcome to today's webinar, Code to Cloud with Microsoft, GitHub, and StackHawk. My name is Morgan Hennessy. I'm the Director of Strategic Partnerships here at StackHawk. Today, we're joined by Dan Hopkins, our VP of Engineering, and Horace Sohail, a Product Manager for Defender for Cloud at Microsoft. Together, they'll talk through how Microsoft and GitHub customers shift security into the software development lifecycle with StackHawk, allowing those organizations to innovate quickly and securely without slowing engineers down. This webinar will be recorded and shared via email in a few days. And for questions, please use the chat function and we'll respond as time allows. So with that, I'll hand it over to Dan to get us started.
All right. Thanks, Morgan. Thanks for that great introduction. We've got an agenda here to talk through. But basically what we're going to do is talk a little bit about StackHawk. I'm sure a bunch of you are a little bit newer to StackHawk than Microsoft, but we'll do an introduction to StackHawk. We'll do a quick demo to kind of set the stage and make sure a lot of the concepts we're talking about stick. And then I'll hand it off to Horace, and he'll talk through some of the Defender for Cloud initiatives and how they fit in. So StackHawk, we are comparatively small to the largest company in the world. And we are a cybersecurity company. We are helping companies to find and fix vulnerabilities before they hit production. That's what's really key. We've built a DAS tool that helps companies to scan their web properties and their APIs, find vulnerabilities, and then fix them. And all of that happens in pre-production. And it happens against a runtime. DAST is always going against a actual running application. And so we test it just like an attacker would, or just like pen testing would, except it's in an automated fashion. So we think of ourselves as a very developer-first testing platform. One of the big tenets of shifting left is to try to find vulnerabilities earlier in the developer lifecycle so that they get fixed before they get out to production, and also so that they get fixed in the most timely manner possible. And so our tool accomplishes that in a variety of ways. As it's kind of mentioned here, we are closer to the code, so we actually will plug right into your CI/CD pipeline. You can scan your systems every time somebody makes a change, and find vulnerabilities actually and give people notes in the pull requests themselves for them to fix. We support a bunch of different types of APIs, the most modern ones like GraphQL, gRPC, and REST, and then also some legacy technologies like SOAP, for example. And our product is really easy to configure. We make it feel a lot like your CI/CD pipelines are configured. So usually customers are configuring YAML inside of their code repositories. And that really keeps everything very close to what they're used to doing, what the developers are used to doing. And in that way, it really fosters this developer-first testing. So appsec today, it can be a very painful process. We hear from a lot of companies that they have an annual pen test. They go through. I led a team at Splunk that worked with our team over in security, and once every 6 months they would come to us with a PDF report of 50 pages of vulnerabilities that they'd found in our product. And we'd go through that process and look at all the different vulnerabilities. And of course, all the engineers, their first question is, well, is this a real vulnerability? Like, how did you do this? And so there would be a lot of back and forth. And this meeting itself, this triage meeting, was like a couple hours long with 30, 40 people, something like that, because you need a huge representative set of the engineering team. And so as a result of that, this testing was always really far behind. And oh, by the way, by the time they got to our 6-month test and did the pen testing and then came back with the vulnerabilities, we'd already shipped 10 new versions of the software. And so it was already out of date with what is going on. And we hear this from companies all the time. We hear that they're testing mostly in production. It makes the most sense to give your pen testers, for example, or legacy DAS products access to production And so that's what people do, and they only think about testing in terms of production. Um, and then, as I was describing, you've got these kind of pen testing, long living pen testing cycles, and ultimately, it's very rare that anything gets fixed unless you bring the hammer of compliance, which is basically, hey, we've got vulnerabilities, they're high, mediums, and lows. They need to be fixed in 30, 60, 90 days. And if you don't fix them, we're going to fail our audit. And that's really the only way you can motivate the engineering or product teams to actually do something about that. And StackHawk wants to fix that. So, as I mentioned, we've gotten really good at implementing StackHawk, at getting it into CI/CD pipelines, at connecting it with people. But that's only one part of the story. There's actually more to running a successful DAST product. Not only do you need to scan systems, but you need to know what systems to scan. That's discovery. And then you need to observe how your whole AppSec program is working. You need to make sure that everything is meeting compliance. Maybe it's being scanned weekly or it's being scanned every time there's a change. Whatever it is, you need to have some sort of posture that you've developed internally and that you need to make sure is happening across all your systems. And then you truly need to be able to scale. A lot of our customers, especially in the mid-market plus region, have 1,000, 2,000 microservices, things like that. And so you need a process that's going to scale across all those different systems. It can't be something where you're just, about production or your API gateway and you're able to scan it. And so StackHawk brings tools around the implementation. That's just our base scanner, around discovery with our recently launched Hawkeye product to discover where your which of your code repositories have testable APIs inside of them, and then observability through GitHub Security Center, Defender for Cloud, or StackHawk's oversight functionality. These all help you to manage the posture of your system, of your AppSec program. We see companies, I've been doing effectively digital transformation for about 15 years. I was at a company previous to this called VictorOps, and we helped companies to adopt DevOps, put their engineering teams on call for the first time. And now I'm at StackHawk, and we're helping teams to shift left, but really this is in the spirit of digital transformation. This is about maturing companies to build software faster, and therefore be more strategic and getting functionality out the door. And there's always a maturity curve that goes along with that. And so StackHawk's shift left maturity curve really focuses on how people are shifting left. And so in phase one here, we're really looking at companies that are either just checking a box, saying that they're interested in shift left, or maybe they're just, kind of running a very manual process, something like that. Then we start to talk to customers who they understand, the basics of shift left, but because so much of what shift left requires is a people and process change, they haven't necessarily embarked on that, but they're looking at tools that can support them. They're doing things like making sure that they've got security champions or building out a bigger AppSec team, things like that. Then we talk to companies that are more in the shift left committed phase of their journey. And these companies, for example, when we talk to them, when they're thinking about buying a tool to support their journey, they actually bring developers to the call. They have good relationships between the security organization and the development organization. They understand the pain and kind of the shared responsibility between the two different groups, right? The engineering team is all about shipping features to production. The security team is all about making sure that everything is safe and that we're mitigating risk. And together, they have shared responsibility to make sure that customer data isn't exposed. And once they start to actually bridge those divides and talk across the groups, we start to see momentum towards shift left. And when they adopt StackHawk, they typically get it all the way into the CI/CD pipeline. They really think about automated testing. They start getting things fixed more quickly, things like that. And then finally, you can get all the way to being continuously secure, which means that things are not even going to production until vulnerabilities are mitigated. And this is kind of what we consider the industry best practice, and really helps you to scale your security program. So I mentioned this before. StackHawk is a DAS scanner. That means it runs scans against systems that are running, but not necessarily in production. Pre-production is where we typically see things going. So if you can imagine, you've got Hawk Scan sitting here in the middle, and it is attacking your application, and this is all inside of your boundary. So we have a small ephemeral process that you can start up on a laptop, which is what I'll show you in a second. But you can also run that in Kubernetes as just a temporary job, or in GitHub Actions or ADO pipelines, something like that, where you're just starting a job, running a scanning application, or scanning and running application, and then stopping. And then the results all get streamed to the StackHawk platform. And I'll show you this in a second. And as it mentions here, we can scan REST APIs, GraphQL APIs, gRPC, SOAP, classic web applications like server-side rendering, things like that. We can also take in custom discovery mechanisms like HTTP archives, Postman collections, things like that, things that basically tell us what to scan. And yeah, so that's basically our solution. So let's talk a little bit about how StackHawk and Microsoft and GitHub, which is part of Microsoft, work together, because we have a lot of places where we all connect. So StackHawk, we do the API security testing. We use Hawkeye's API discovery mechanism as well. And then you can buy our product through ADO's marketplace and Azure's marketplace. You can automate the scan through ADO's pipelines or GitHub Actions. And then you can integrate our product into many different places. So we can send findings over to ADO boards. We can send notifications or alerts whenever there's a new finding to MS Teams. We integrate into GitHub Security Center through CodeQL. We've got an integration with CodeQL. You can see the results of your scan right in the PRs in GitHub that are coming over. And then we integrate with Defender for Cloud into the CNAP. And Haros will talk a little bit about that more in depth. Integrating StackHawk into GitHub Actions is super simple. You create a YAML file as a build in GitHub Actions, and that kicks off the scanner. And then in our system, you map your code repositories to your StackHawk application, join those together, and then we'll actually match CodeQL findings to the findings that StackHawk found to give you more certainty that something is a real finding. So let's jump into StackHawk. I'm going to stop the presentation. Oops. And let me just share the rest of my screen so we can.
Hey, Dan, and as you bring that up, the new
Yeah.
screen, we have a question in the chat as well. Somebody was asking if StackHawk also works for other environments like AWS as well. Did you want to speak a little bit to that part as well?
Yeah, absolutely. So we can scan any web application. So if that web application runs in AWS, if it's running on EC2 instances, or lambdas. As long as they expose HTTP endpoints, we can scan them. I think that we'll show some of the benefits. That's like at a raw scan level. I think that Horace and I are going to show some of the benefits between Microsoft and StackHawk, where you get a little bit more than just the scan results. But yes, it integrates with AWS as well. Okay, so I have over here, everything for us starts with a scan. So I'm going to kick off a scan, but we're not going to watch it run for very long. But I've got a running web application here that we've created. It's called Java Spring Vulny. It's running on my local host port 9000. And it's a very simple web application, but it has some known vulnerabilities inside of it. So StackHawk is really easy to kick off. You give it an app ID, and then you just tell Hawk scan, and it picks up the configuration from a local YAML file that's running in this same directory, and then begins scanning. And so what we'll actually see here is that the web server that's running right here will start spitting out a bunch of errors, like non-200 responses, as HawkScan attacks it. And that's how you know it's working, is that you start to get output. But for the demo, what I can do is this is the StackHawk platform. And over here, I can jump into the scans page, and I can actually see the scan that we just started, Java Spring Vulny, right here. And we get real-time progress about how it's going. And over here, we can see all of the different types of tests that we're running. And so this is, actively being updated as we watch it. So that all these different tests, it's counting the duration, tells you who started the scan, things like that. And then in real time, findings are going to start populating over here. And one of the things that's really interesting, the first place to point out the Microsoft integration is that you get this static analysis finding as well. So let me click into this finding, the cookie without secure flag. And we've got here in the findings details, we talk about what's going on. What is a cookie without secure flag vulnerability? Where did it occur? It occurred in the login code. We give you the request and response and how we knew this is a vulnerability. And in fact, you can validate it locally by just getting this curl request. And then because you've integrated into GitHub's CodeQL, they have a finding over on their side that matches our finding. And we actually correlate those together. And so now I can jump from a running application and actually go right to the line of code where this vulnerability is happening. And this helps security to tell the developers that, hey, this is real and we know where in the code it's happening. And then it really helps the engineers to know what they need to fix more quickly. And then I was mentioning that you got to import your code repositories and then link them to a StackHawk application because we need to know which CodeQL repositories to look at. And so just briefly how that works, over here I have connected to GitHub and imported all of these code repositories. And then we actually process them using AI to figure out which one of these code repositories has a running application inside of it. And those get marked with the little sparkles here, and they get added to your attack surface. And then your attack surface, you can map an application to that code repository, and then that helps us, makes it possible for us to take the findings from that application and link them back to the CodeQL findings. And so, the scans done now, usually our customer scans are less than 10 minutes. There's a virtuous cycle here that if you can make really fast scans, then your scans can go into the CI/CD pipeline, and you can actually find vulnerabilities as the software engineers are writing code, and therefore they're much more likely to get fixed because they know what's happening and why a vulnerability just appeared. Okay, any questions about any of that? Did we have anything else come through? Okay. I think I'm going to turn it over to you, Horace.
Awesome. Sounds good. Thanks, Dan, and thanks for that great demo as well. So yeah, with that, what I'll do is talk a little bit more about now how this whole piece with StackHawk really integrates with the overall Microsoft security solutions as well, specifically with Defender for Cloud. So let me just share my screen here. Great. So we'll be talking through basically how StackHawk can kind of help enable with Defender for Cloud more full lifecycle, both application and API security. So we'll talk through the runtime security capabilities in Defender for Cloud and how all this kind of comes together. But before I go into that, just wanted to give a brief intro into Defender for Cloud as well for anyone that's new to this platform. So Defender for Cloud is what we call our Cloud Native Application Protection Platform, or CNAPP platform. And we basically break the kind of values of Defender for Cloud into three distinct pillars. The first of which is really unifying your DevOps security management. So the idea here is, as a security team, you need to have visibility into what your development teams are doing, what security scans are running, and their various developer pipelines. So for example, across GitHub, across Azure DevOps, across GitLab, for example, you want to make sure that you have visibility and governance of whatever security scans are being run in those pipelines. So that's one of the first key pillars of Defender for Cloud. And this is also the pillar where we integrate with StackHawk as well. So we'll talk a little bit more about that once we get to the demo piece as well. The second key pillar is really cloud security posture management. So you can think of this as more proactive security controls that you can enable across your various cloud security resources, right? So for example, you might have various cloud resources like virtual machines, app services, functions, Kubernetes containers, for example, and all of these can have misconfigurations, right? They might not be abiding by best security practices. So that's really the goal of Defender for Cloud, is to really bring that forward to the security teams. Hey, you have some rogue virtual machine that's not abiding by best security practices, go and fix it, for example. And you can also see this in context of risk prioritization, and we'll talk a little bit more about that as well. But the idea there is you can also see if you have really sensitive applications, like applications that are exposed to the internet or maybe containing sensitive data, that can be used to help prioritize different security recommendations as well. So that's on the posture side. And then the last key pillar is really to protect your cloud workloads with CWPP. And the idea there is really now your threat detection piece, or more reactive security. So if somebody were to actively exploit any of your cloud resources, can we have the right monitoring and alerting in place to make sure that your security teams are aware of that? So all of these three capabilities are part of our broader platform called Defender for Cloud. And this platform is not just available for Azure security, it is multi-cloud and multi-pipeline as well. So for protecting your AWS workloads, your GCP workloads, and even on-prem and hybrid environments as well. So there's kind of a brief intro into Defender for Cloud. And then I'll talk a little bit more about how we approach API security, specifically on the runtime side at first. And then the next slide, I'll go over a little bit more details about how we integrate with StackHawk to really enable that full lifecycle approach for customers as well. So this is actually going over our runtime security offering in Defender for Cloud called Defender for APIs. And Defender for APIs can also be broken into these three pillars that you're seeing here. The first of which is really classifying and understanding the security posture of your API. So the idea here is you might have APIs that are transferring sensitive data, APIs that might be dormant, there might be inactive APIs, external exposed APIs, and APIs that might not be abiding by best security practices. So for example, you might publish these APIs within your various API gateway systems, but maybe they're misconfigured. Maybe they are not abiding by the best security best practices. So this will bring visibility into that. And then the last pillar is really monitoring and protecting your APIs against attacks in runtime. So we have a full set of both machine learning and threat intel-based security detections to assess against any active exploits against your APIs. So this really ties back to the OWASP API related security risks. So that's basically an open source company, or sorry, a company that's kind of gone together and put together the best practices and kind of highest risks when it comes to API security. And they've enumerated the top 10 risks when it comes to API. So we really use that as kind of a benchmark when we're building our various security recommendations and threat detection capabilities as well. So the idea with the monitoring is you can protect against those top OWASP API related risks as well. And as a first piece to this, the integration is available with Azure API Management. So for any APIs that you have published within Azure API Management, you can go and enable Defender for APIs for those APIs. So there was kind of a summary of the existing capabilities that we have available on the runtime security side for API security. But as I mentioned, really to have a full approach to API security, you need to take this with a full lifecycle kind of a mindset in this case. So this is where the integration with StackHawk comes into play, where StackHawk can help enable some of the more dev lifecycle protections. So just when you're starting off with API security, even figuring out what's out there by discovering unknown APIs and applications, as well as actually protecting and dynamically testing those APIs, like with the demo that Dan showed. And this is a really important piece, as there's many specific API-related vulnerabilities that can really only be assessed by testing. So there's only so much that we can do on the runtime side. There is a certain set of vulnerabilities that need to be tested more proactively, and that's where StackHawk can come into play. And then on the runtime side, we have Defender for APIs, which can go through all the various aspects I just walked through of security as well. And together, that really bridges the gap and creates this full lifecycle API security approach for customers. So that's really the vision with kind of full lifecycle API security coverage. And then the next part I'll walk through is we actually have an integration in place, of course, with StackHawk as well, with Defender for Cloud. So the idea here is, as a developer, you can go and run your various StackHawk scans within your DevOps pipelines. And then as a security team using Defender for Cloud, you can now get visibility of those results within Defender for Cloud. This is now available in public preview. And this is available both for GitHub and Azure DevOps as well. So with that, I'll actually cut to a demo to actually go and see this in action. Great. So here I am in a sample repository. This is that same Java Spring Volney application that Dan was talking about here. So this is basically an application with seeded vulnerabilities with both API security and web security threats. So in this case, we've already set up a GitHub workflow to run the StackHawk scan. So I can go here to the workflows, and I can see I have this StackHawk new YAML file. And in this case, you can see that this particular workflow kicks off anytime I make a new change to the main branch, or on a periodic cron job as well. So I can run this on a weekly basis, for example, if I would like to. This will basically kick off the StackHawk security scan. And then once the scan is done running, we will actually upload these results to the GitHub code security scanning tab as well. And that's basically the prereq needed to get these results into Defender for Cloud as well. So I'll showcase that piece here next. So in this case, we've already run this workflow before. I'll go to the GitHub Actions. And you can see we ran that workflow before. You can see that when it ran, it actually did find various vulnerabilities. So you can see the run hawk scan step here. You can see that it came back with all these various vulnerabilities that it found for your web application in this case. And then you can see that those results were also uploaded to GitHub code scanning as well. So we can go and actually take a look at that here. So within the GitHub Advanced Security Code Scanning tab, you can see that we have 30 alerts showing up. And these are all from that same hawk scan in this case. So let's say, for example, we click into this one, SQL injection. You can actually specific StackHawk report where you can actually see all those results show up in this case.
Hey, Horace, I think you lost your screen there.
Oh, you lost my screen? Oh, let me retry that here. Great. Are you able to see my screen?
Yes.
Perfect. So yeah, this is basically wrapping up the developer workflow. So the idea here is that as a developer, I will work in GitHub. I can actually see the specific vulnerabilities as they come in, and I can see the steps I need to take to go and fix that as well. All of that is available here within this page here. But as a security team, I might not have access to all these various repositories, right? It's very difficult to manage that at scale. So in this case, this is where the integration with Defender for Cloud comes into play. So the next part I'll walk through now is going to Defender for Cloud. So here we are within the Defender for Cloud overview portal. And here what you'll see is I can go into the recommendations tab, and I can actually just search for API security testing. So right now, this shows me all of my security recommendations across all of my various cloud resources. I can filter this list down by just searching up for API security testing here. And now you can see that same repository, Java Spring Volney, showing up here as well. So in this case, let's go ahead and select it and click into this recommendation. And here you can see GitHub repository should have API security testing findings resolved. And you can see in this case that I have all of those same findings showing up here. So I can go and click into this. In this case, you can see content security policy, CSP header is not set. And I can actually go and view that finding in GitHub if I would like to as well. So this is really the goal of the integration, is now as a security team, you have visibility if somebody's pushing any insecure code into production, for example. So this basically brings that unified visibility across all of your repositories in this case. So that's kind of the first part of the integration. And this also works with some of the other more advanced feature sets that we have in Defender for Cloud as well. So for example, if I go over to the Cloud Security Explorer page in this case, I could go and easily create a query in this case to show me all of my code repositories across my entire organization, in this case, that have that specific recommendation. So let's just filter here, show me all of my code repositories that specifically have that API security testing findings that need to be resolved. So in this case, I can see here, I have for Azure DevOps and for GitHub as well. And then let's say, for example, I'm only interested in repositories in this case that allow public access. So we see that we have maybe hundreds of recommendations. We need to prioritize those, the ones that are publicly accessible. So the ones that are basically allowed for public access, those repositories, those might be of highest concern to me. So now I can quickly filter that as well. And I can see a full list come back of those same repositories in this case that run that StackHawk scan, but also allow for public access. So in this case, you can see we have a few repositories showing up here. So that's really the goal with Defender for Cloud and really the integration that we have in place with StackHawk. So as you can see, you can now get unified visibility of those results from StackHawk Scan within the Defender for Cloud portal for your security teams to go and take action. And that's all I had here for the demo. I'll cut back here to see if anybody has any questions.
Oh, I think we lost you again, Horace. Yeah, so we have one question here about what type of analytics can I see? Is this related to in Defender for Cloud, or is this just overall like how your security program is doing? Both? Yeah, great question. So in StackHawk, as I mentioned, we have new capabilities called oversight that looks across your security program from StackHawk's perspective, to see how your find versus fix ratio is going, how fast things are being fixed, things like that. And so Horace, the question was basically, what types of analytics can you show in Defender for Cloud, maybe about how your security program is doing?
Yeah, definitely. So within Defender for Cloud, basically the goal with Defender for Cloud is really focused on all up cloud security. So the idea here is not just seeing API security in isolation. Instead, you can see really security results across all of your cloud resources. So if you have virtual machines, if you have serverless functions, if you have app services, if you have containers, all of those will have unique risks present within them. And you can see really all of those results show up within Defender for Cloud. So if you have any misconfigurations across all of those different types of resources, that will show up in Defender for Cloud as security recommendations. So that's one level of kind of analytics, really configurations, misconfigurations across your cloud resources. The second level of analytics is more so on the runtime threat detection side. So you'll also get actual logs as well. If somebody is doing any sort of malicious or suspicious behavior, you can see those show up as alerts within Defender for Cloud as well. So if somebody's accessing your Kubernetes cluster from a suspicious IP address, for example, or accessing your API from a suspicious IP address, that will show up as a Defender for Cloud alert as well.
Nice. We have another question here. Is there any walkthrough documentation of StackHawk's capabilities and how they integrate with different cloud providers? Great question. The documentation for StackHawk is at docs.stackhawk.com. And we've got lots of documentation talk about how you would scan different API gateways and things like that. And then if you go to just stackhawk.com, you can actually start a free trial and talk to our team, and we can help you get spun up in scanning just about anything. And then last question is, why should I go for StackHawk when there's so many other security tools in the marketplace? What is the advantage that I get? I think the key things that I highlighted around really connecting with your development process, I think more than anything, this shift left is about three pillars, right? It's about people, changing the way that people interact. It's about using a process that facilitates connection between the two silos of security and development. And then it's about buying the tools that support the changes to the other two. And I think that being able to plug into your CI/CD pipeline, having a scanner that's fast enough to be part of a engineering workflow, the comprehensiveness that we have, the OWASP top 10 for APIs and web applications, things like that. And then our ability to really understand the scale of the problem by taking in code repositories, 1,000, 2,000, 10,000 code repositories, and point your security team at these are the ones that actually have running APIs inside of them. These are the ones that you need to be getting under test. I think for all those reasons, StackHawk is a great choice.
Great. Well, thank you, Dan and Horace, for presenting, and thank you to all of our attendees for joining. Just make sure to check your email over the next few days for a copy of the presentation and also a recording of the webinar. So thanks again for your time and have a great rest of your day.
Bye, everyone.
Thanks, everyone.